In this video, we are going to show how to use the Pascal Triangle. The topic of binomial expansion is a topic with so much content, and we are not going to unload all those content in one video. We may have to devote something like at least six videos just for the topic of binomial expansion. And so what we shall do today is show to you how to use or how to interpret the Pascal Triangle. So this is the Pascal Triangle. And these numbers will tell you the numerical coefficients of a binomial when you raised it to an integer power n. So let's say, for example, x plus y raised to 0. You know that it is equal to 1, okay? So that is just 1. That is your numerical coefficient. When x plus y is raised to 1, the coefficients are just 1 and 1. So take note, okay? So we are not just expanding any binomial. No. What we are expanding is the binomial x plus y. How about when we raise it to 2? What is x plus y squared? These numbers are going to be the numerical coefficients of your expanded binomial. It's going to be 1x squared plus 2xy plus y squared. The same with x plus y raised to 3. We already saw this from our previous video. The numerical coefficients are 1, 3, 3, and 1. What other pattern can we see from the expansion of a binomial? So let's say, for example, let's pay attention to x plus y raised to 4. How many numerical coefficients do we have here? We have 5. So that is telling you that when you raise a binomial to an integer exponent n, the number of terms of the expanded binomial or polynomial is going to be 4 plus 1. 1, 2, 3, 4, 5. So the expanded binomial is going to contain 5 terms. So let's say, for example, x plus y raised to 6. How many terms are you going to see when you expand it to the 6th power? You will see 6 plus 1. That's 7. 1, 2, 3, 4, 5, 6, 7. So again, our concern in this video is how to use the Pascal Triangle. I know you are kind of lost. Where did this number come from? We will devote a separate video for that, on how to generate these numbers. But for now, our concern is how to use the Pascal Triangle. So let us interpret the meaning of each of these numbers. For x plus y raised to 2, these numbers are the numerical coefficients of the terms of the expanded binomial. So, 1x squared plus 2xy plus 1y squared. How about x plus y raised to 3? Okay, so how do we interpret these numbers? Okay, so the first term is going to be 1x cubed plus 3x squared y plus 3 again, that's the numerical coefficient of the third term, 3xy squared plus 1y cubed. How about x plus y raised to 4? Again, these are the numerical coefficients of each term. 1, 4, 6, 4, 1. You must be careful with how you are writing the terms of your polynomial. We spoke about this last time. The pattern of descending integer exponents. Look at this. This is the first term. It's raised to 4 because your polynomial is a degree 4 polynomial. But look at the pattern of descending exponent. X to the 4th, x cubed, x squared, x to the 1, x to the 0. So you have x to the 0 here, which is equal to 1. On the other hand, the other term, y, the second term of your binomial, is showing ascending integer exponent. So from y raised to 0, that's 1, y raised to 0, it becomes y raised to 1, y squared, y cubed, y to the 4th. So let us use the Pascal Triangle. So let's say, for example, this is our polynomial. expand x plus 1 raised to 4. So we will look for the fifth row. Okay, so this is raised to 0. 1, 2, 3, and 4. Okay, it's raised to 4. So if you were now to expand this, you will see 5 terms. And what are the numerical coefficients? 1, 4, 6, 4, 1. Okay, so let us write it down. Again, the pattern in writing the first term of your binomial, descending integer exponent. And, well, fortunately, the second term is only 1. So 1, 4, 6, 4, 1. These numerical coefficients can be obtained from your Pascal triangle. Let's say, for example, our polynomial is x plus 1 raised to 7. Raised to 7. So this is a degree 7 polynomial. We expect to have 8 terms. Okay, so let us look for the degree 7 polynomial. These are the numerical coefficients of this polynomial. So 1, 7, 21, 35, 35, 21, 7, and 1. As for x, again, you just follow the pattern. Raised to 7. So this should be a degree 7 polynomial, and then it's going to be descending integer exponent. X to the 7, x6, x5, x4, x3, x2, x1, x0. And x0 is just 1. How about x minus 1 raised to the 5th power? Expand this. I spoke about this last time with x minus y raised to the 3rd power. What you do is you write the binomial in terms of addition. X plus the negative of 1 raised to 5. And then we will look for the row corresponding for the polynomial of degree 5. This is it. So these are the numerical coefficients of the terms of this expanded binomial. Okay, so let us write it down. So again, my advice to you is follow the pattern. Okay, do not simplify it yet. Now look at the descending powers of x. X to the 5th power. 4, 3, 2, 1, and x to the 0. Now look at negative 1. Negative 1 will show ascending integer exponents or ascending integer exponentiation. From negative 1 raised to 0, that is 1. Okay, so you have negative 1 raised to 0 here, but that is just 1. And then the quantity negative 1 raised to 1, then raised to 2, then raised to 3, 4, and 5. Now, how about the numerical coefficients? Well, you just copy the entries in your Pascal triangle. 1 is the coefficient of the first term. 5, look at that, 5, 10, 10, 5, 1. And then after that, that's when you simplify the terms of your polynomial. Okay, you apply the law of signs. So this one is going to be minus. Negative 1 squared is just 1. So this is going to be positive. This is negative 1. This is just positive. This is going to be negative. So it's going to be minus 1. So this is it. This is the expansion of x minus 1 raised to the 5th power.